The Puls Cuno Cargo Hold Meteorological diagram. Is this a diagram from the ancient century, or is the diagram still advisable and how to use the diagram? That will be the question what we have to answer, and what I like to demonstrate to you how to use this Puls Cuno Cargo Hold Meteorological diagram. For the prevention of damages to hygroscopic goods or cargo, like in bags or in bulk, like grain, the most important item is for sure an optimal ventilation of the cargo. So which means for the ventilation, all the instructions shall be given in detailed and in short information, and they should be correct information regarding the ventilation of the cargo. This ventilation requirements should be also part of the voyage plan documentation and should be part of the toolbox meeting for the intended voyage, especially if we are carrying special hygroscopic cargoes like grain, or if we are, for example, carrying steel cargo, which also have to be correctly ventilated if we have to ventilate the cargo. So what have to be on hand to actually analyze what is required on ventilation is the temperature. That means the outside air temperature, dry and wet, and also the dry and wet bulb temperature from the cargo holds. That are the requirements for analyzing if I have to ventilate or if I do not have to ventilate. And for this reason, we can use the Puls Cuno Cargo Hold Meteorological diagram. And this diagram is still a good tool and a good assistance in decision-making process for the master and the officers to know if they have to ventilate or if they do not have to ventilate. So what is the content? We have here down on the abscisses, we have actually here the dry bulb and later on also the dew point temperature. Then we have here this one. This is actually the curved lines are the relative humidity, that is from 10 to 10%. And then we have here the diagonal lines, this one, that are the wet bulb temperatures. So this is actually the content of this diagram. And this diagram was actually published in 1977 by Puls and Cuno, two German meteorologists. And the whole diagram is divided in 6 different parts: A, B, C, D, E, and F. And the way how this diagram is divided remains always the same, regardless what temperatures, dry and wet bulb temperature I have, the buildup of these fields are remaining. So which means for each field we have a certain, let's say, a consequence and a certain ventilation regulation. That means if we have to ventilate or if we do not have to ventilate. So let's state if the dry and wet bulb temperature of my atmospheric temperature will be here in the field A, here, so, which means it is possible to cool and dry the cargo by ventilation with all possible capacity for exhaust and supply. If the dry and wet bulb temperature of the atmospheric air will be here in this field, always based on the actual wet and dry bulb temperature from the cargo hold, then B says carefully ventilation in order of cooling and drying cargo is possible. It should only be exhausted, which is to be watched because the values of the area B are very limited. If it is in this area, in this field C, then slight ventilation shall be done to avoid sweat at ship's construction. The hold are to be checked very frequently because wet water can develop at the surface of the cargo near the ventilation opening. And if it is here in this field D, it's only possible to dry but not to cool the cargo. Properly it will warm up and biological reaction will be encouraged. A drying effect is reached even if the ventilated air is cooled down to cargo temperature. Coming to E and F, which are the versus one. So which means E and F means if my atmospheric air temperature, wet and dry, will intersect in these fields, the outside humidity is higher than the hold, and water vapor will be transported into the cargo hold and into hygroscopic cargo. In particular, in area F, ventilation should be stopped to avoid sweat to cargo surface, but the same is also with E. So to avoid that there will be a water vapor transportation inside to the cargo. So let's have a small demonstration how it works by using an example. So this is our example. The voyage is with grain on a bulk carrier from the US East Coast to Dar es Salaam, which is the east coast of Africa. The cargo hold temperature on departure is 14 degrees, which is the same as the air temperature. The total distance is given, 9626 nautical miles, with an average of 14.5 knots. I would use 27.7 days. So for the voyage, what we see, we have 28 degrees in Dar es Salaam, we have 14 degrees in the US East Coast. That means the voyage is from cold to warm. That means the ventilation is not essential and should be not always done, only if it is absolute necessary. So let's have a look. After the first 3 days, the atmospheric temperature is 19, with a dry bulb, with a wet bulb of 14, and the cargo hold temperature is 15 degrees and the wet bulb is 9 degrees. So now what we have to do is we take our diagram and we are now entering into the diagram the given values. So what we had was 15 degrees and 9 degrees. So which means the wet bulb was 9 here and the dry is 15 here, so which means it intersects here. So therefore now we can create our fields. So here we go to the left side, parallel to the dry cargo temperature abscesses, until we are reaching the wet bulb temperature curve here, and then we go straight down until we are intersecting again with the abscesses for the dry cargo temperature, and this one here is our dew point. So the next one is that we are starting to follow the curved line. That means the intersection with the dry and wet bulb temperature here. So now we have to follow this line until we are intersecting here with the line perpendicular down to the abscesses. And now we can mark our area. This is B, this is A, and this is C. So which means this is always the same, always remaining the same. So we're extending now the dry temperature and go to the right side perpendicular to the abscesses, and here at the end also to the right side. And then we have already our final areas, D, E, and F. So my temperature, my air temperature was 19 degrees with 14 degrees at the wet bulb. I will now enter this. So I have 14 here, until I intersect with the 19. Here, that is actually the intersection. So I'm intersecting here with wet and dry bulb in field E. Here's my intersection point. So what does it mean now to me with regards to the ventilation? So let's check it. So here was my intersection. So which means here field E says risk of water vapor transport inside the cargo, the dew point, and therefore also the vapor pressure and the absolute humidity are higher in the atmospheric temperature than in the cargo hold temperature. That's what we can see, because if we would here go down, we're coming to 14 degrees as a dew point, and here we have a dew point of about 1 or 1.5 degrees. Ventilation will result because of the vapor pressure differential of ventilating air to the cargo. We have here ventilating air is 19, the cargo temperature is only here 15. And I will bring in then more humid air. Then I have also a water pressure differential between this ventilating air and the cargo hold air. And this will result in a humidity transport inside the cargo. Ventilation can cause cargo damages due to cargo sweat. So which means here it is for sure advisable to stop the ventilation and not to ventilate to avoid this effect. So if we are now 12 days later, we find this, then we are in field F. Field F is more risky than field E, so which means we additional to the characteristics of field E, the risk of cargo sweat is given because the dew point of the atmospheric gas above the cargo temperature and therefore also above the dew point of the cargo hold temperature. No ventilation. So which means for each day and the time I have to take the temperatures, the dry and wet bulb from the cargo hold, and this is the basis of this diagram and for the fields, and then where the intersection with my atmospheric air, wet and dry bulb temperature is, that will be then the field where this temperature will be in, and that we have to check if ventilation is required or not. Okay, that's it. How to use this cargo meteorological diagram to prepare it. And you see, it is actually not a big problem to prepare such a diagram. It's also very fast. If we are keeping always the same locations in the hatch where I do the measurements and not using different locations, that is number one what I have to observe, then this diagram is quite nice. And it is really, if we do this like here, but you can see here on the screen is that we have an evidence on hand, an evidence what we have done and why we have ventilated or why we do not have ventilated. Okay, thank you very much for watching. Bye-bye.